Okay, so we have a question here. How many even numbers are there in the sequence which are immediately preceded by an odd number but immediately followed by an even number? Okay, we have how many even numbers are there. So we have to find even numbers which are immediately preceded by an odd number. So there is an odd number before but immediately followed by an even. So we have to find odd, even, this three pair of three numbers consecutively. Okay, let's start. For simplicity, what we are going to do is we are going to find two consecutive even numbers. Okay, and then we'll check if there is an odd number before that, those two. Okay, this makes it simpler to find out odd, even combination. Okay, let's go. 5 1 4 7 3 9 8 5 7 2 6. Here we have two even numbers and there is a odd number here. This is counted. Then we go further. 3 1 5 8 6. We have 8 6 here, odd number here, counted. Then we go further. 3 8 5 2 2 4. We have a 2 2 here, odd number, counted. We also have a 2 4 here, but there is an even number here, so this is not counted. Then we go further and that's it. We have three numbers which satisfy the given conditions. However, make sure that you also count this when you count even, but it is not counted because it is not preceded by an odd number. So our answer is 3. Let's solve another one. How many odd numbers are there in the sequence which are immediately preceded and also immediately followed by an even number? Again, let's see how many odd numbers are there. So we want to find odd numbers which are immediately preceded and immediately followed by an even number. Now there are two sentences here which are clubbed by conjunction and, but we understand the meaning, right? What does it mean? There is an even number before and there is an even number after. So this is the combination that we are going to find: even, odd, even. Okay, let's go. Odd, even, odd, even, 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 odd, even, odd, even. This is one combination. Now again, we do not start from 6, we start from 3 8, because if you see here, this is another combination which is even, odd, even. Okay, next we start from 2 2 4 3 4. We have one here and we have another here. Okay, most likely what you're going to miss is not starting from 8 here and from 4 here. Okay, make sure you do not start from 5 but you start from 8. So we have 4 such numbers. Let's solve this one. In the following series, how many such odd numbers are there which are divisible by 3 or 5, then followed by odd numbers and then also followed by even numbers? Okay, a bit trickier. Let's bifurcate the sentence. How many such odd numbers are there? We have to find odd numbers. Now this should be divisible by 3 or 5. This is the second part, 3 or 5, and then followed by odd numbers and then also followed by even numbers. Okay, so we have third sentence here, then followed by odd number. So here should be an odd number and then also followed by even number. So there should be a even number. So this is the combination that we are supposed to find. However, there is another condition here, that this first odd number should be divisible by either 3 or 5. Okay, so easier thing here to do will be to find out two consecutive odd numbers where first odd number is divisible by 3 or 5. Okay, let's go. Two odd numbers, then two odd numbers, 21, 20, 21, 45. We have, that's it. These are the only 4 pairs of two consecutive odd numbers. Now in this first pair, 19 is not divisible by 3 or 5. This is crossed. Here 21 is divisible by 3, but the third number is 25, so again this is not counted. In 325, 3 is divisible by 3 of course, and third number is also even, so this is one pair counted. When we go for 2145, of course this is divisible by 3 and there is an even number here, so this is also a required pair. And that's all. Main trick here is to not miss 21-3, because when we find 19 and 21, we miss 21-3 as a pair of odd numbers. Also, another trick here is to figure out how to proceed. Here we figured out that we first will find two consecutive odd numbers and then proceed for multiplication, divisibility by 3 and 5, and then even numbers. This is what you have to figure out what to solve for first, and we have our answer. Okay, let's solve another one. In the following number sequence, how many such even numbers are there which are exactly divisible by its immediate preceding number but not exactly divisible by its immediate following number? Okay, let's bifurcate the sentence. How many such even numbers are there? We have to find even numbers which are exactly divisible by its immediate preceding number. So whatever here is divides the even number but not exactly divisible by its immediate following number. So whatever here is should not divide the even number. Okay, so let's find even numbers first. Okay, here 1, 2, 8, 4, 8, 4, 2, 8, 2. Okay, now the following number here should not be dividing that even number. Basically, this even number should not be multiple of this number. Okay, if we see 4, 8, 8 is divisible by 4. Okay, so this one will not be counted. Okay, similarly here this 4 is divisible by 2. This will not be counted. Here again will not be counted. Okay, now we have remaining. If you see this 4, 8 is not exactly less than 4, so 8 cannot be a divisor of 4. So again this will not be counted. Here if you see this 8 has a preceding 2 and followed by a 3 which does not divide 8, so this is one pair. Okay, make sure you do not miss these 2 as well. If you see 2, 7 is not 7 cannot divide 2, and That's why this is not counted. Okay. If you see 4 here, 3 is not a divisor of 4, so 4 is not counted. For 8, 4 is the divisor and 9 is not a divisor, so we have another pair here. Okay, we have a 2 here, but 4 is greater than 2, and that's why this is also not a divisor. Similarly, for this 2, 8 is not the divisor, and that's why we only have 2 pairs here. Again, our trick here is to find the first even numbers, then figure out which even numbers you can discard first. Figure out which even numbers do not meet the given condition. That's when you go and find what are the required numbers. We have another question here. Nathan was counting down from 32. Sumit was counting upwards from 1, and he was calling out only odd numbers. What common number will they call out at the same time if they were calling out at the same speed? We have one sentence here, counting down. So Nathan, Sumit, counting down from 32, Sumit counting from 1, but only odd numbers. So 1, 3, 5, 7, and so on. Okay. What common number will they call out at the same time if they were calling out at the same speed? So same speed means whenever Nathan says 32, Sumit says 1. Whenever Nathan says 31, Sumit says 3, and so on. So if you see here 28, 27, 26, 25, 9, 11, 13, 15, 24, 23, 17, 19. When he says 22, when Nitin says 22, Sumit says 21. And when Nitin says 21, Sumit says 23. So there is no common number that they will call out at the same time, given that they are calling at the same speed. Okay, so the answer is D.